Hey guys, and welcome to the ACT Science data representation video. So I'm going to make the same kind of little speech that I did in the last video, the research summary video, at the beginning and the end of this video as well. So if you are confused at all about anything in this video in terms of question types, if perhaps you'd like to see another example of a particular question type, a lot of the same sorts of questions are on both data representation and research summary. To a much lesser extent, the conflicting viewpoints passages, because they're pretty much a different animal entirely. But a lot of the same questions are on the first two passages, the first two videos. So if you want more practice, I suggest looking at both videos because both of them will help you with the other type of passage. Okay, and I'll also, give you a little note about that at the end of the video, but that's my little note for you guys. Okay, so on to data representation. So like it sounds, data or data, however you like to say it is fine, representation is a passage that represents a bunch of information. So, whereas research summary, the way that you can quickly tell if it's research summary is if you see experiment 1, experiment 2, or researcher 1, researcher 2. In data representation, you have to have some sort of table, chart, or graph. If you don't have a table, chart, or a graph, then it is not data representation. In fact, if you don't have any sort of physical picture, it's probably a conflicting viewpoints, because that is the only type of passage where more often than not you don't have any sort of visual aid to help you understand what's going on. So data representation will be any number of charts, graphs, etc. A lot of times it's one huge chart. Sometimes it's up to 3 or 4 different charts that are explaining something. And if you're kind of unlucky, you get one huge complex chart that has a ton of different information on it. But no matter what size or format your chart, graph, etc. is in, you're going to approach it in the same basic way. So we're going to go ahead and go over the way that you're going to approach it in a second, because we'll do that right before we actually look at a data representation passage and work on it. So in the meantime, let's go ahead and go over the sorts of questions you're going to see on data representation. And again, some of these are going to be the same or similar to what you would see in a research summary passage. Okay. Oh, and side note, I should have written this down. This is also, just like research summary, 3 out of every 7 passages. So, they're tied for the most important type of passage that you're going to see on the ACT Science test. And, it's all about understanding charts. So, understanding charts, graphs, etc. Okay, so let's go ahead and go over questions now. Okay, in data representation, you have 2 basic types of questions. You have figure interpretation and you have patterns questions. Unlike our previous video, research summary, you don't really have to deal with scientific reasoning questions because there generally are not, a bunch of different experiments. So you're not going to be delving into how they performed an experiment, why they performed an experiment. You're going to be dealing with the terms that they give you, and also what do you think would happen if you put a different sort of term into the equation, or if you tested a different variable based on the graph that they give you. So data representation questions are going to be, a lot of them, just figure interpretation. So what that means is that you're looking at a specific line of a chart or a table, a specific point of a graph, and you're just explaining, what that variable is telling you. So in trial 6, you have a certain percentage of oxygen, for instance. The other type of figure interpretation question that you're going to have in data representation, which isn't so common in research summary, is you're going to have to explain what a figure is telling you. So most of the time when I say figure, I mean, a graph, a chart, a table, some sort of picture, any sort of visual representation. Doesn't matter what it is, still counts. But for this specific type of question, you're only going to look at a picture that's trying to explain what's happening, and you're going to have to be able to explain what that picture is showing you, and sometimes you even have to infer some information from the picture. So this is like specifically having to do with the picture. And the pictures are always going to be, figure 1, figure 2, etc. So for the pictures, you're doing the same thing you were with specific plot points in a graph. You just have to understand what it's showing you. So pictures, understand and occasionally, explain or translate what's going on with some other additional information. So figure interpretation is basically testing your ability to read a chart or a graph. Figure interpretation questions in research summary tend to be pretty straightforward and pretty easy because their tables and graphs tend to be, fairly small. In data representation, you'll sometimes end up with huge tables or huge charts that have so many different variables on them that it's a little bit harder to find what you're looking for. But the same idea applies. You're going to read the question and look for exactly what pieces of information it wants, and then you're going to have to find it. So, for instance, in a research summary, they might ask, in trial 1, what was the temperature reading? So you would just go straight across and look, okay, trial 1, keep going across until you hit temperature. Okay, it was 10 degrees Celsius. Perfect. In data representation, they're much more likely to give you several different pieces of information, and then you have to find what's going on. So, at a height of 10 meters, an initial mass of 5 grams, and a and a theta of 30 degrees, what was, according to, table 1, what was the projected distance that a ball would travel? Okay, well, in that instance, it's not just saying, oh, in trial 1. So you're not going to have to read straight across. You're going to have to take the information that they gave you and then look for those specific points of information within the graph, table, chart, etc. So it gets a little bit more complicated, but the idea is exactly the same. So just look for whatever it is that they're asking for. Okay, our next and really important type of question is patterns. So for patterns questions, you're going to have to look at the chart, look at the graph, and realize what's the relationship between the variables. As one thing increases, does something else increase? As one thing increases, does something else decrease? There are certain variables that are not going to have any relationship to each other at all, and that's completely acceptable. That's fine. That's just life. But anytime there is some sort of clear relationship, you're going to want to note that. And the more complex you get in terms of the charts that they give you or the graphs that they give you, the more often you're going to have keys. So, for instance, in a patterns question, you're not just going to have an X and a Y and then one line, which would say, okay, X and Y are directly related to one another, aka as X gets bigger, Y gets bigger. P.S. direct, indirect correlations, independent variables, etc. None of that is actually tested in terms of terminology on the test, but the idea is there. So they'll say as one thing increases, the other, your answer is increases, rather than saying, X and Y have what kind of relationship, So instead of having something really simple like what I just drew, you'll have several different lines. So let's say that. Okay. And then they'll have a little key at the top that'll explain. And obviously your lines would have to be, a little bit different. So say one of them is really thick. This line is really thick. This line has little dashes all over it, etc. So it'd have to explain like a line equals this, a line with dashes equals something else, etc., etc. So the more complicated they get, the more often you'll have things like keys to try to explain what's going on. The trick is to just, treat it like any other graph, any other problem. You're just looking for the information that you need at that specific time. So a lot of patterns just have to do with relationships. So relationships, super important. Sometimes they'll actually make you plot the data. This doesn't happen as often as it would on Research Summary because they tend to plot the data so well for you already, but it does show up sometimes. And then the idea is that you're looking for things like, what would happen if you had a data point that's not on the graph. So let's say you're extending your x-axis and you're looking at this thick line. Where is it going to hit 0, for instance? So you're looking at data that's not on the graph, chart, etc. So in terms of that, the idea is assume that the pattern continues. So patterns are consistent. If they weren't consistent, then it wouldn't really be fair. So if something is continually increasing, you get to assume that it continually increases for the rest of time. If it's decreasing, it decreases. If it's an exponential curve, that it's going to increase or decrease exponentially. If you had a line that, is kind of doing this totally random, they can't ask you the kind of question that would say, what happens at this point over here. It wouldn't be fair. If they were to ask you something like that, then your answer would have to be, there is no way of knowing this, or not enough information has been given to determine. So they won't ask you that because it's just not really fair. So assume that patterns are always consistent, unless they give you some reason as to why they would not be. And then they also can ask you about entirely new variables. So they can ask you about, so I have my key with 3 things on it. They could add a 4th thing and say, how would it react given the following information? And it would have to be similar or dissimilar to your other lines, your other variables, in a consistent enough way that you could figure out how it would react. And you also can do, it also will ask you things like, where is the optimal, or what temperature is optimal for all of these reactions, for instance. So you're looking for where your variables are the same. So in the little teeny chart that I drew, there's one point where our thick line and our curved line meet. That would be the optimal point at which, you could get both of these things. So, because if you go further than that, then you have more of the curved line item, whatever that variable is, and less of the thick one. But at that joint point, that's where you have the same amount of both of them. So you also are going to be asked to look for specific interesting points on the graph. So it's kind of a double-edged sword in that for data representation you have less different kinds of questions, aka you're not going to be asked to do the more scientific reasoning kind of questions, but because you have less overall types of questions and the same number of questions per passage, you tend to get a little bit more complex, either figures, charts, etc., or complex questions. So the hard thing with data representation most of the time is that you look at it and you think, okay, wow, that's a lot of chart. There's a lot of things going on in that chart, or there are 5 different charts that I have to be able to deal with. Most of the time they're going to limit it to 1 to 3, but even 3 can be a little bit overwhelming at times. So the key for these is you go through and, as you're reading, you just kind of figure out, like, what are the key points on this chart? If it's a graph, what's on the X? What's on the Y axis? What are the key points? Are there any patterns that I see? The more that you can quickly, has to be quickly, figure out, what's going on, what are the key points, what are the patterns, the more that you've already answered any questions before you actually see them. And that keeps you really accurate, and it also doesn't allow them to throw in questions, or throw in answers rather, that are going to confuse you because they seem right or they seem attractive even though they're not actually correct. Okay, so as promised, let's go ahead and go over the method for how you're going to deal with data representation passages, and then after that we get to look at an actual passage.